Hello, everyone. Welcome. Thanks for joining us at this webinar today. My name is Kate. I'm going to be moderating. We have Tua here and Ola who are going to be doing this great webinar about the iMotions API and its applications. But before we start, we have a ton of great stuff to get through and it's going to be action-packed, but I wanted to just mention a few quick housekeeping things. This recording will be sent to all registrants, so if you need to hop out early and you might have colleagues that might have missed it, for example, everyone will receive the recording of this webinar in 24 hours, so not to worry there. And if you have questions, please drop them into your question box on the right side of your screen, and we're going to have a Q&A at the end. So we will go through the presentation, and hopefully some of the questions you may have over the course of the hour will be answered there, but we will also be answering them at the end. So just submit your questions there into the question box and we'll get started. On that note, I'm gonna turn off my camera and let Tua and Ola take it away. Ola, you're muted.
Can
you hear me?
Yes.
Okay, good. Sorry about that. So, well, once again, thank you and welcome to the iMotions webinar about the iMotions API and applications. So what we are covering today is pretty straightforward. We have an introduction to iMotions. That's going to be with the focus on what's relevant for the API. And then we're going to dig into what is the API and how can it be used. And then we have two use cases that we're going to cover in detail. And hopefully at the end, there's some time for questions and answers. There we go. Yeah, so today we will be presenting myself, Ole Jensen. I'm the product director of iMotions, been with the company for 15 years. And Tua Peterson, he's our senior customer success manager. Has been with the company for 4 years, I believe. You can correct me if I'm wrong. I think that's enough introduction for now for the hosts, and then we're going to go into talking about the company in a while. But before doing that, we just want to advertise briefly the two use cases we'll dig into. So Tua will present a case about wearables, using wearables at the iMotions API. More specifically, he has built an API application or middleware that takes data from this polar belt that measures heart rate through ECG, and then uses MATLAB as a bridge to get data into iMotions. And I believe he also will talk a bit about how we can build custom pipelines for the data that you acquire using this belt.
Correct.
I myself, I will talk about how you can achieve bidirectional communication between iMotions and Unity. So we're going to use the shimmer sensor accelerometer and then use that information to control a virtual car in a virtual environment, and then send data back from Unity to iMotions. So we get a closed loop example out of that. A little bit about iMotions. If you're not familiar with us already, we are a biometric research platform company. We build a software that can synchronize all the different types of modalities that you see on the left side. It could be eye tracking, galvanic skin response, facial expressions, and so on. So we can acquire all this data, synchronize it, visualize it, and analyze it. At the same time as presenting stimuli on the screen. So it could be, well, it could be screen-based stimuli, but it could also be physical stimuli. And what you'll notice here in this overview is that there's also an API. So there's an API on the input side here on the left, at the lower left. But there's also API on the output side on the lower right. And that's the theme of today's talk. The API is relevant also for stimulus presentation, and we'll get back to that in a moment. In terms of use cases, there are many use cases we could talk about. Here are some examples. In-store research with eye tracking glasses and physiological sensors. It could be mobile testing, mobile device testing with eye tracking and other sensors. But it could also be simulations, virtual reality, and gaming. In particular, the API can be useful for these applications because we can set up iMotions to communicate with the simulation, both getting information from the simulation, the game, or the virtual environment. But it could also be sending data from iMotions into the simulation in order to perhaps change parameters in the simulation based on physiological changes. And that's actually covered by the use case that I will be talking about. So let's dive into the API. We'll start very high level. So the API is something that allows the iMotions application to talk to something that's not iMotions using some kind of communication protocol. So that's as unspecific as we can be, but still say something about what it does. To be a bit more concrete, we can say that there are sort of three main uses of the API. We can use the API to connect to sensors. So it could be sensors that are not already supported by iMotions. So if you remember my previous slide, we had all these different inputs. They are represented by different hardware types. So for eye tracking, we have 5 different types of eye trackers or eye tracking vendors that we support. But if you had an eye tracker that's not supported by iMotions, you could potentially use the API to get data into iMotions that way. Or it could be an EEG headset or a galvanic skin response sensor or something completely different. I'll give you some examples in a moment what that could be. Then we have environments, which is another word for saying stimulus presentation. So it could be using the API to communicate with some kind of custom stimulus presentation or another stimulus presentation solution than the one iMotions offers. And then we have the third category, which is workflows. We are not going to talk too much about that today, but the API actually allows you to automate certain things around using iMotions. So instead of having to do a manual click of a button, you can actually send commands to iMotions to do certain things like exporting data, importing data, start recording, stop recording, and things like that. But that's not what we are going to talk about today. In terms of examples for sensors, here are some. A small selection of all the cases we have had in the past. So for example, we've connected to the sensor suite from Biosignals Flux using an LSL connection. And we have connected to the NearX FNears device using the API. Actually, Tu has some experience with that. So if you have questions around that, he can answer that. And also, as an example of data streams that are not about physiological data, because it can really be any kind of data stream you can send in through the API. The CAN bus. So if you're doing, for example, human factors research in automotive industry, you might want to synchronize physiological data with data from the car itself. And a CAN bus adapter is a device that can take vehicle data and stream it out, and we can then receive it in the iMotions API, given some kind of transformation, and then synchronize that, for example, with the eye tracking data. So we have done that in the past as well. In terms of environments, there are 3 examples here. ePrime is a popular example of how to use the iMotions API. For example, if you want to build gaze contingency paradigms, you can use ePrime for that. iMotions will be the software solution that acquires the eye tracking data from one of the many eye trackers that we have support for. As we are saving the data, we're also streaming the eye tracking data out. And then you can build these gaze contingency paradigms in ePrime because ePrime will receive the eye tracking data in real time and do something with that. Unity is also a popular example, especially in academia. It's a very popular platform to build games. It can be actual games, but also serious games or simulations. So you can regard Unity as not just a gaming platform, but a very advanced stimulus presentation environment where you can do basically everything you can imagine on a computer screen. The last example is a somewhat more a special case, but an interesting one, because we often talk about visual stimuli, but you could also imagine having aromas or scents as stimuli. And that contraption you see on the picture there is a device that can deliver aromas on demand. So we have used the API in iMotions to trigger aroma release at an ideal point in time. So you can imagine if it's about smelling something, the respiratory cycle is important. So in this case, we use the iMotions API to measure the respiration of the participant, detect where in the respiratory cycle they are, and then release the aroma at the ideal moment in time when they're about to inhale rather than exhale, for example. So that's somewhat of a special example, but shows the versatility of using the API. If you talk to someone in iMotions about the API, this is the terminology that we often use. So we could say input API is all about getting data from the environment into iMotions. It is also referred to as the event receiving interface. And then there's the output API, which is about streaming data out of iMotions. So all the sensors that we are connected to, we can connect to. You can save the data, but you can also stream it out in real time, receive it in your own application in order to do something with it, which is exactly what the example of ePrime is, or the example that I'm going to show you later with Unity is. And then there's the remote control interface, which is about this automation of workflows that I talked a bit about before. And lastly, we have the lab streaming layer, which is a recent addition to the iMotion solution. LSL is getting increasingly more popular. So often you'll find sensors from various vendors that can communicate via LSL. And since iMotions has an LSL inlet, then there's a good chance that if that sensor has support for LSL, you can directly plug it into iMotions. It's not always successful because there can be different interpretations of the protocol, LSL protocol, but often you can get it to work out of the box. And to become a bit more concrete about the API before we go into the use cases, we talked about iMotions it can communicate with something that's not iMotions using a protocol. Well, that protocol is basically just network communication. So it could be a TCP or UDP connection. The kind of messages that are communicated either from iMotions or to iMotions are formatted as you see here in the top right. So when you receive data from iMotions, you get a series of events, and each event has an identifier to tell you what sensor does this data originate from. In this case, it's from Affectiva. And then you have a number of semicolon separated values that each represent a channel from that sensor. So that for the face expression algorithm, it could be joy or anger, surprise, and so on. So they are represented by these numerical values. When you send data to iMotions, then it's basically the same principle. You need some kind of identifier. In this case, it's called generic input. And generic input has two values associated. And you need to somehow tell the system how that looks like, how many values are being sent. And we will actually get into that in a moment. Everything is described in the iMotions Programmer's Guide, and that can be accessed in the Help Center. So if you have access to the Help Center, you can just go and find it there. And we often get the question of what kind of programming language is supported in the API, and it really doesn't depend on the language because it's just network communication. But popular examples is Python and C# and MATLAB. And we're actually going to show an example from MATLAB today, and also C# because Unity is based on C#. And I think that's it for the introduction to the API. And then I'm going to hand it over to Tue. And Tue, you just tell me when I have to change slides.
Yeah. Well, good evening and good morning, everyone, depending on what time zone you're in. This is actually quite anxiety-provoking for me since I've never presented any sort of public code. But this was sort of a good opportunity to clean up some of my code a little bit and give you a very good example of a little experiment that I've been playing here with, namely to use a consumer sort of grade chest strap to stream heart rate and heart rate variability data into iMotions using MATLAB as a middleware. So that's what I'm going to spend the next 10 minutes speaking about. I was very much inspired by when I downloaded MATLAB 2020, and they actually had this really great example of how you could use, how they now support these Bluetooth low energy communication protocols. And the sensor that I'm using and I'm actually wearing right now is this Polar chest belt that's about 100 euros, and you can buy it in any electronics store. And they actually do a really good job on the chip in the Polar belt to collect the raw ECG data and then stream that on this Bluetooth low energy protocol. It also means that you can collect data for hundreds of hours without actually having to change the battery. So that's what I'm going to show. So next slide, Ole, please. So now, why is this important? Before, I'm not a programmer, actually a human physiologist of education, and obviously heart rates and more specifically distances between individual heartbeats, known as the R interval here in the ECG, is quite important actually, because we can use heart rate variability as an index of emotional arousal or emotional regulation. And as I've illustrated here on the right side, we normally extract interbeat intervals as the time between two R peaks. So that's really the ventricular contraction of the heart. So the distance there would be the interbeat interval. And then you can, from that signal, you can do different computations. What I've shown here in the lower case, in a lower figure here, would be a frequency transformation, looking at different frequencies that are present in the R intervals. So it's a very tempting, easy to use technique to gain insights into emotional arousal and emotional regulation. Yeah, next slide, please, Ole. So here is, I'm just giving a few examples here of how easy it was actually to build this kind of interface between the Polar chest band and then iMotions. Really here in the first 6 line of codes is just establishing connection to the Polar belt, and it happens to be so that these Bluetooth low energy devices, they all work. They have standardized protocols known as GATT, and you can look them up on the Bluetooth homepage, and from there you can sort of see what are the different characteristics of a specific device, and if a device has a certain characteristic, in this case heart rate, you kind of know what to expect when you connect to it. So you know what the data should look like when you receive it, which is really, I think, a really strong argument for using these protocols. It is sort of unique. So I also connected to a Garmin watch at some point. It worked just the same way. So here in the lower lines of my code, this is essentially what Ole told. We're using a network protocol. Here I'm just connecting to a local host. I'm using the port 8089. That's the definition in iMotions. I've set it up to be that way. So here, when I receive a response from iMotions, when I establish the connection, basically my code moves on, and then I'm sure that I have a established TCP connection to iMotions. You could also use UDP in this case. It doesn't really matter, but in this case, I was just using the TCP to the local host here. Yeah, next slide, please, Ole. So here is really the sort of what's going on behind the scenes. For the first part of the loop here, I'm basically setting up a stop button so that I can start and stop my code as I want to. That's probably less important, but here you see what is defined in line 32 and 33 are really the strings that the text strings that Ole talked about. These are semicolon separate values, so I define them from the beginning, and then I basically just insert my heart rate and R data in between, and then we have to fill in this cartridge return message so that iMotions knows this was like one message that was sent. And then you can see here I'm creating a loop that continuously reads the data from the Polar device. There is a new notification of data once every second, and there are certain flags in that. There is a flag in that message that tells me, what the format of the data should be, which is also pretty straightforward when you look up the GATT specifications. And then really down here in line 44, 45, and so on, this is a case where I'm not receiving any R intervals. I'm just receiving the heart rate. So I'm creating an entire string, like a text message. That's my 2 iMotions, and then I'm turning that into a native ordering, and then I'm basically writing that to the TCP port, and that's really what it's about. If you go to the next slide, Ole, please. Some devices, and in particular the Polar device, will also send RR data. So there's a chip on the belt that actually processes the ECG in real time, and from that derives the RR interval, and that's sent here as a 16-bit unsigned integer. And so I'm converting that here to something that I can send to iMotions. And basically then I'm passing that to my complete string here and sending that along with the heart rate data. There's also a conversion. You can see here, this is the resolution of the band that's also specified from Polar. So I need to convert it from a bit to milliseconds in this case. And then what happens on the Polar belt is that sometimes when I receive a Bluetooth packet, I actually receive more than one RR interval at a time. Since the device is only sending at 1 Hertz, if I have a heart rate that's slightly above that, I'll actually get more RR intervals in the same packets. So here I'm setting up a check for that. So if I receive more than 4 points of data, then I make sure to send the second RR interval again right after the first one. And we don't have any timestamps present. The Polar doesn't give me any timestamps, so I just have to send them right after each other. But that's not a huge problem here, since there's sort of an inherent timestamp already built into the RR interval itself, since it is timing between 2 beats. Okay. Yeah, if you move on, Ole. And lastly, I have to configure iMotions API so that it knows what to expect. So again, here I've just inserted my code. These were my start and end strings here, and then I passed my data in between. And then I've defined a small XML file. I've loaded that into iMotions API here in the event receiving interface. And it's a really straightforward XML file to work with. It basically has an ID and a name similar to what is in my start string. And then it defines, in this case, 2 field IDs, one with BPM, so beats per minute data, and the other one is RR interval data. And then I've chosen here to set the scaling in iMotions to a minimum and maximum for both time series of data, because that's kind of what I expect the heart rate to be between 40 and 200 beats per minute, and the RR interval to be well within the 200 to 1200 millisecond range. Okay, next slide, Ole. And finally, just to highlight some of the features that we actually have in the software. Back in the days when I started here, everything was hard-coded into the software. So whenever we had to build a new analysis pipeline, that had to be built in the iMotions platform. But we have slowly transitioned all the analysis into R scripts. So we can run R scripts on the time series data in the background. So really, you can take any signal that you collect in iMotions and then modify an R script to run data analysis on. So here, with a great help, I must say, with the help from my 2 colleagues here, Ramli and Amandine, they actually within half an hour managed to change the R notebook that we already have for heart rate variability analysis, and have that read the heart rate and RR data that I was streaming into the protocol, so that we could do a standard heart rate variability data on the Polar data that we collected. So I'll show you that a little bit later, what that looks like. But basically, it's the same analysis that you would expect from any normal heart rate variability analysis software. Like probably a good example of that would be Kubius, that a lot of users tend to use within this field. But it also shows how versatile the software has become, in the sense that you can take any data, feed it in through an R script, and then do analysis on it right away. All right, Ole, I think we can go to the next slide. Oh, this is where I actually supposed to do the live demo. So I'll just grab the presentation rights here and show my screen. So can you see my screen, Ole? If you can confirm.
Yes.
Okay. So I'm just going to run the code here that you saw snippets of on the last few slides. Let's see if it runs here. It does, and what happens is that in a few seconds it will bring up a list here of different Bluetooth devices within the range of my computer. So we have a TV here also in the office, but here is the Polar that I'm wearing, so I'm going to connect to that. And then if we then head over to iMotions, we will see here, we will actually start streaming in data here through the API, and these are the names that you saw before in the XML file, named the beats per minute here, the heart rate, and here are the RR intervals. And I can tell you my heart rate is a bit higher than usual at rest, but that would be sort of expected, I guess. So you can see here also, to confirm the Polar device is streaming data basically every second, so it's a 1 Hz signal. And again, here we have the heart rate, the beats per minute, and you can actually verify here the correct nature of the RR intervals, because you can see that the RR interval is modulated by the respiration frequency, which is a very sort of common phenomena in RR interval data, that they are modulated whenever there's a higher sympathetic input during inspiration phases. So that's kind of what we expect here. And then obviously I could build a study in iMotions, and these data would then be synchronized with whatever I choose to display on the screen. If I quickly jump one step further and really just to basically finish this small demo off, I've cheated a little bit here and did a TV kitchen thing where I collected some data a few days ago. In iMotions, I can show you that here in the live viewer. This is just a 2-minute sample of data that I collected. And so again, here on the top are the R intervals, and here's the beats per minute. And I then ran our small R code on that. And so you can actually see the metrics here. So overall, in this case, I had an average BPM of around 76 beats per minute. And you can then see here the derived parameters for the heart rate variability analysis. So here would be a typical parameter to report the root mean square of standard deviations here, which is in this case around 20.48 milliseconds. And what you typically see in experiments is that this value would decrease when you have an increased arousal level, and it would tend to increase when the arousal levels are decreasing. So that would sort of be a typical expectation for heart rate variability analysis. And this is of course visualized here in the software, and there's also an export that gives you these data in a CSV file format for further analysis. I think that was what I had to show. I will pass the presentation rights on to Ola again, and then he will do the next kind of live demo.
Yeah. Do you see my screen again?
Yep.
Very good. All right, so the second use case is about how we can make iMotions communicate with Unity bidirectionally. So sending data to Unity and getting data back from Unity. The end result will look something like this. It's kind of a made-up use case, but it illustrates the point, I believe. So we have a virtual environment with a virtual car. And the job for me is to control that virtual car using the accelerometer data that's streamed out from the shimmer sensor, which you see there in my hands. And then at the bottom, we have these graphs, which represent the position of that car in a virtual environment. And those graphs are achieved, they're obtained from data coming from Unity. So let's see how we achieve that. So yeah, these are the components of the solution. So we have a shimmer sensor. It connects to iMotions that can acquire this data. That's something we do every day. But what's special about this is that it forwards the data on the API. And then we have a Unity environment, which in this case is just a standard asset downloaded from the asset store. And we have a Unity car, which also is a standard asset found in the asset store. And then we have two scripts, and that's basically where the work was done. So one script in Unity is built to receive data from iMotions. The other one is to send data to iMotions. And then we have modified a little bit the car control script. But the emphasis of the next few slides will be on the two scripts to receive and send data. So this is the flowchart of the data. So iMotions here on the left side, it's configured to receive data from Shimmer, and it's configured to forward that data over the API, or the output API, if you will. All that information is being broadcast on localhost port 8088. And Unity is then set up to listen for this information and extract the accelerometer data. Then there's a transformation of that accelerometer data that happens in real time in order to input into that car vehicle object something that it understands in terms of forward motion, backward motion, left and right turns. And once we have done that, then Unity is programmed to then send back to iMotions over localhost port 8089 the position of the car. the X and the Y coordinate of the car within the environment. And iMotions is then configured to listen for these events and understand how they are formatted, pretty much like what Tu just described. Not to repeat everything that Tu said, but this is how it was configured. So actually, Tu didn't talk about this part, so this is not repeating what he said. So we are forwarding the data from iMotions basically just by clicking a button here in the global settings to forward the iMotions events. And if you were to listen for these events in some kind of application that listens on the network, the data that we see will be formatted as shown here on the right side. So a bunch of events coming out. For each event, there is an identifier from what sensor they originate from. In this case, it's a shimmer, but we could also imagine having multiple sensors. And then the identifier is, of course, necessary to filter that data because we are only interested in shimmer data. And then we have those semicolon separated values that represent different channels from the shimmer sensor. So the challenge is to identify the accelerometer data in this data set and then do something with that. And that's exactly what this script does. So this receive data method lives somewhere inside the belly of Unity. And the first thing it does is that it connects to a UDP port, iMotions, the port that iMotions is broadcasting on. And then there's this while loop, which is also very similar to what Tu showed in MATLAB, that just keeps running throughout the entirety of the experiments. And then every time we iterate, we are listening for new messages. And if there's a message, then we want to make sure that it's a message from the shimmer sensor, which is that third box there. And then lastly, we extract from that message the accelerometer data. And the position is 9, 11, and 13. And I'm happy to talk about how I identified those indexes, but maybe that's for some later conversation. All right, so now we have received the data in Unity. Then the other way around, getting data from Unity to iMotions is actually very much identical to what Tu just explained. So we have sort of a custom-made method here. It's very logically called send two numerical values to iMotions. It takes two inputs, value 1 and value 2, which of course will be the X and Y position of the car in the virtual environment. And then constructing the string, we have an identifier that's called Unity2 inputs. So now iMotions knows what to listen for, and those two values are piped into that string. And then it's being broadcast back to iMotions on the port number that it expects, 8089, I believe it is. Yeah. So this is the configuration on iMotions. Again, very similar to what Tu showed you. So I have an XML definition that tells the system what to look for. So the token is Unity2 inputs, and it is instructed to receive two values, value 1 and value 2. We could have called them X and Y just to make it more logical, but just to be generic, it's called value 1 and value 2. And now it's time for the demo. So we have iMotions running already. I have the shimmer sensor here, and we have the API ready to listen. I actually have more information than what I talked about being streamed from Unity. I might have time to return to that, but I'm going to focus on just one of them for now. Let me see here. Yeah, I have, hopefully you can see that we have the accelerometer graph here. So whenever I move the sensor around, the accelerometer responds to this movement. And the challenge is, of course, to communicate this to Unity and then make it control the car. So that is already being built. And if I open the application, actually, before I do that, I'm just going to add myself here as a respondent. So I'll start the recording. All right, and then start the environment. And I'm gonna move this thing here so you don't see that. And the two video feeds. It's a lot of moving parts here, so forgive me if I'm not saying anything right now. How do I get rid of these camera feeds? Yeah, all right, there we go. Okay, so I can now start controlling the car, and you can see just move it over here. So you can see how I'm going to drive around the house. I'm going to take 2 loops, and I have been practicing this the past couple of days, so I should be able to do this without crashing into something. And then once I've done 2 loops, I'm going to challenge myself and see if I can find a difficult spot to navigate the car into. All right. And I'm also recording the GSR data at the same time. So the idea here is, of course, if you are interested in, for example, gaming, you could imagine, oops, yeah, no, this is getting too difficult. Yeah. So if you're interested in gaming, you can get this game telemetry data, and you can synchronize that with the physiological data from the sensor. So I'm going to end the experiment here. Tango is not focused very well on this task. But to demonstrate the point about synchronization, let me just close the environment. All right. So now we have the recording. We can review it. And what you'll see, let me just move this over here. We have the GSR data on top. And then we have the, let me just remove those 2 here. And look this up. All right, so there we go. So what we have here is the GSR data on top. So we can see how the GSR is moving up and down as I try to navigate this environment. And then you have value 1 and value 2, which is the X and the Y position of the car as I'm driving through this environment. And so we have this game telemetry data, and then of course you can imagine starting to build some correlations between the physiological data and the game telemetry data. So from the X and Y position, we could extract something like speed or acceleration. Maybe we can also start to look at making mistakes and how does that look like in the raw data, and then correlate that back to the galvanic skin response, for example. Could also imagine using the ECG belts that Tua demoed before in combination with this. So now you could add heart rate variability on top of what you see here. And then just to illustrate also the analysis aspect, so we can obviously start to analyze the GSR data and then correlate that back to the experience and the game telemetry data. So, oops, there we go. 1 second. I'll just add in here our GSR notebook, GSR peak detection, and then let it process. All right, so if I open the recording that I just made, you should have the GSR peaks, and these are the peak times and peak amplitude. So now we have all this information in one interface. So the raw GSR data, the game telemetry data, the screen recording of the environment, the camera feed of what was I actually doing with the sensor, and then we have the peak detected here, when are the peaks detected, but also information about the amplitude of the peak. So all this information can then be put together into one big analysis. Yeah, I think that was it for me. So I'm gonna throw it back to Kate so we can take the Q&A session.
Thank you so much, both of you. That was really awesome to see live, super nerdy and fun. So we are going to take a few questions. I got some good questions coming in that I see, so but keep them coming. We have still about 15-20 minutes left, so please ask your questions. I'll do my best to moderate them. But before we do that, I just wanted to ask if we can follow up with you in any way. How can we do that? So we actually have just a little poll for you. If you want to just fill that out, I will launch it now. And while we're doing that, while you're answering, I'm going to ask a few questions. So we have some good ones. So I'll start with this one. when would you two recommend using RStudio or MATLAB with iMotions data? Is there a preference? What would you recommend? Is it the type of study you're doing? Just curious about what your recommendations are.
Yeah, I can start adding to that. For me, it's more a personal habit of using MATLAB, since that's what I've been doing throughout my entire academic career. I'm actually not sure of whether R as such has the capability of establishing TCP connections and do stuff similar to what I did here. What I have seen though is that I've seen similar code to what I just showed you here from Python. So there's definitely been people doing the same thing that I just did using Python instead, and obviously that's attractive since it's free to use, and there are quite a lot of different tools that you can use there. So I've also seen more and more people moving all their analysis into Python. So I think it's more of a personal preference what people are used to code in.
Okay, great. And if you out there in the audience have questions about that and working with your iMotions data, you can definitely reach out to us or to your customer success manager, and they can help you recommendations for how to analyze your data. Great. I'm going to give the poll a couple more seconds, maybe 30 seconds, and I will ask the next question to make sure everyone has a chance to vote. We have a question here about how many polars, Tua, in your example, how many polars can be tracked at the same time? And if more than one, how would you deal with interference of signals?
Yeah, I saw that question popping up in the chat. I'm actually not sure. I've seen that people connecting several polar watches to the same phone at the same time, so essentially having multiple polar streams on the same phone. I haven't tested it in my code whether you could connect to multiple sources at the same time. I think for iMotions API it wouldn't be a major concern, since you would just have to define I guess separate XML files. This would be your polar 1 and this would be your polar 2. But I'm not sure how it would work from a coding perspective. But I'm happy to test it out further.
Okay, cool. Yeah, if people in the audience are curious about that, you can email us at marketing@imotions.com, and then we'll connect you with Tua.
Yeah, of course.
Cool. Great. I'm going to close that poll now. It looks like the majority of people have voted, so thank you so much for giving your input. I'll close that. And next question here, we have some people asking about automotive industry specifically, probably inspired by your demo, Ole. Do you know whether people in the automotive space are using this type of sensor research data in conjunction with braking, for example, like with ABS systems?
No, I actually haven't heard about that, but I could imagine that someone would be interested in something like that. But I have no concrete experience with ABS braking systems, unfortunately.
Mm-hmm. Do you think that could be something that people could do with iMotions?
Yeah, potentially. I mean, of course, safety applications, you have to be extra careful what you do. So don't copy paste any code that I made for that. But of course, the campus data is interesting, right? In this context, because you could get information about the engine status and braking status and so on from the canvas. I believe it depends a little bit on the car model whether that data is readily accessible. If you are the automotive manufacturer yourself, obviously you have access to all the data that you need. But if you're a researcher trying to answer that question and not having access to sort of the engine information directly, then of course it could be somewhat more difficult to do. So potentially yes.
But we did do a project for Ford in Denmark around 3 years ago, actually looking at driving experiences during braking and acceleration, and that was done on a closed track. Just to comment on your safety, Ola, and I think there's still a YouTube video of that experiment actually online.
Yeah, it's on our blog too.
Yeah, and so we were looking at different driving experiences, and I believe that actually the whole campus integration was made for that particular project.
Yeah. Cool. Okay, we have another question about Unity. Are these Unity functions that you demonstrated, Ola, are they inbuilt or would you need to code them yourself?
So, I mean, to be perfectly honest, everything that has to do with connecting through UDP connection, what I showed you there before, that is just like standard code that you can find many examples of online. So I would say, to be completely honest, 80% of what you saw today is copy-paste work. You just need to do it in the right order. So what I'm hoping to do is to actually put this on the help center, so that if you're interested in working with this kind of streaming data in and out of Unity, you can just get the example from the help center, and that hopefully will save you some time.
Awesome, great, that's really exciting. We have a bunch of more questions coming in, so I'm just going to keep firing them. Can you maybe talk a little bit more about the R notebooks that you mentioned? If people haven't heard about the R notebooks beyond what you guys mentioned, a great sort of 2-minute explanation would be awesome about what has been changed since the hard coding and how you access them, etc.
Will you do that too?
I can do that. I was waiting for you, but that's fine. Yeah. So essentially, we've slowly started to transition all of the analysis into R code. So what it really means that it has the advantage of us being able to change or modify, or customers can modify our notebook pipelines for analysis without us having to change, have to release basically a new version of iMotions. It also has, the flexibility that everything is documented. It's open source, so you can open up the scripts if you're interested. You can look at the documentation in there. You can see the references for different papers that we've worked from. So it gives us a lot of flexibility to do time series analysis and visualize it back into iMotions, and we can write export in the future, also visualizations from R. So it makes us less dependent on the software itself. So I've had a couple of examples where clients were asking for specific metrics or specific modifications for time windows for EEG analysis, and that's something that we can change very rapidly, which we couldn't do just 3 years ago. So I see that as, for me personally and for some of my clients, it's a huge advantage. And yeah, and also the open source approach to the whole R coding, I think, is a great advantage.
Yeah, exactly. The transparency is awesome, so you can actually see what is going into your calculations and your analysis. It's really awesome. Cool, thank you. We have a question about sampling rate. Do you want to talk a little bit about is there a max sampling rate that iMotions can acquire for signal acquisition using the API? Are there some guidelines about that we need to take into consideration?
I can answer the first part of that question. So there is no sort of set limit on the sampling rate. I think there is probably a practical limit. First of all, like you cannot send 44 kilohertz data in like audio streams, for example. We tried that in the past, and you will probably get some lag, and also iMotions is not built to process raw audio data. So I wouldn't recommend that. Most applications for the API that I've seen, and Tu can perhaps confirm that, is like less than 1,000 hertz. But that's one dimension. The other dimension is like the number of channels that you communicate. So one channel, 1,000 hertz, that might be fine. But if you have 100 channels at 1,000 hertz, then you might run into some bottleneck issues, right? So I cannot give you sort of a simple answer to it, other than if you have a specific project, ask us if this is feasible through the API, and then we can guide you from there. And then, of course, the other approach to that is to try it and test it. But you can also just ask before you start investing time into it.
Mm-hmm.
Yeah.
Yes. Great.
I agree.
Tu, did you want to add anything?
No, I agree completely. We have tried it with 44 kilohertz on a LSC, and that seems to be sort of not possible. But on the other hand, I've seen 800, 1,000 hertz of a few time series working just fine.
Okay, great. Awesome. We have time for a few more questions. So we have actually a few questions about off-the-shelf sensors that you might have seen, like, for example, Garmin or Fitbit or even the Apple Watch. What kind of things can we do with that in terms of the iMotions API? Or is there something that you can share on that note?
Yeah, I can say that, you know, all the devices that support low energy Bluetooth would work pretty much off the shelf with iMotions API if you're able to build a small middleware as I just did. And since they all comply with the SCAT specifications, these standards, and how they communicate and what the characteristics are and how they broadcast, the code I showed you here was built for a Garmin watch that I had, and then I changed it into a Polar. And it was really just changing the name of the device because everything else was, you know, had the same format. I'm not sure that Apple allows you to actually stream data in that way. But what I'm currently also trying with the Polar is that it should also be possible with that to stream actually raw ECG data. So I guess the limitations, you know, they really are what, you know, what a device, what you would like to get, whether it's just heart rate, whether it's heart rate and RR intervals, or whether you also want to access the raw ECG data. And then I think there can be some limitations in custom data that, for instance, Polar, probably don't want you to see, you know, what they're actually doing on the chip, but they stream some kind of treated signal. But so that depends. But there are certain standard characteristics like the heart rate R intervals that are, you know, equal across all the different sensors.
Nice. Great. Cool. I'm gonna ask one more question and then we're gonna close it out and let you guys know what's coming up next. So we have a question about more than the statistical programs you mentioned, like Python or MATLAB. Have you heard of folks using iMotions to do AI or machine learning? Can you think of any examples of that?
So, I mean, I think you can see iMotions as a part of a pipeline in those fields, right? So, because the same software connects to all these different types of devices, if you want to do research into sensor fusion, I think the word is, then iMotions is actually a good platform to do that, because you can collect out of the box easily physiological data across many different kinds of modalities with eye tracking, facial expressions, and so on. And then you get one data set, one way of representing all of that data. So you don't have to be bothered with, you don't have to yourself be bothered with one SDK for one modality, another SDK for another modality, and then bring it together. You basically have one entry point into all of that information that then could be piped into a machine learning project, or deep learning, or AI for that matter, as training sets. But iMotion sort of stops there when we hand off the raw data in a nicely formatted way, and then your job start like by taking that data and then do something with it. So that would be my answer to that question, but maybe Tu has something more to say.
No, not really, unfortunately.
Okay, cool. I think that's a great note to end on it. I think the possibilities are endless. It's all just about your ideas and your use cases. So we're always here to advise you, and we can answer any questions that we didn't get to during this webinar if you email us at marketing@imotions.com, and we're happy to take that conversation. If you go to the next slide, I just want to let you guys know that we also have another exciting webinar coming up that you can find at imotions.com/events if that's not where you signed up for this one. In a couple weeks time, we're doing a webinar with our partner Vario, where we will be talking about healthcare training in VR. So we're gonna have a demo where we're showing how to train healthcare professionals in a virtual environment so that they can get ready for actual clinical environments. So that is on May 27th, and you can find out all the details on imotions.com/events. And then final slide, please, Ole.
Yep.
Cool. And then you can always just connect with us on LinkedIn. We're at iMotions, so find us there. And a ton of our employees are super active, and they'll be there to answer any questions you might have there as well. And if you didn't request during the poll that you'd actually like to have a demo customized for your own use case, you can go to iMotions.com and /request demo and get one there. And there's a ton of other options to be in contact with us. So we're here to answer any questions and consult you on your use cases. iMotions is super broad in its applications, and we've seen a couple of those today. So like I said, the possibilities are endless, and we're looking forward to hearing from you. So on that note, thanks so much, Ola and Tua, for being with us. Thank you, audience members, for your great questions and your engagement, and we will see you soon. Thanks a lot.